ch14, chapter 14, phasors, problem number 42. It says perform the following subtractions in rectangular form. I'm going to do part C. So they have this vector minus 36 plus j78, and then you subtract -4 minus j6, and then add a 10.8 minus j72. So you have to group all the real numbers together. You take your -36 minus a -4, which is +4, and then plus 10.8. That ends up equaling -21.2. And then you group your imaginary numbers. So 78 plus 6, that's a -6. Don't forget to distribute that. And then the minus 72. So 78 plus 6 minus 72 equals 12. So then your answer is minus 21.2 plus J12. Problem 43, it says perform the following operations with polar numbers and leave the answer in polar form. What I did, and again, you're strongly encouraged to use your calculator. I really want you guys to use your calculator that can do complex numbers here. So here's an example of the polar form. You have your z, your magnitude, your theta, your phase angle, and you got to watch when you start getting the negative numbers and negative phase angles. This is the negative side, so going around in the counterclockwise direction is the way we normally go positively, but this is the negative direction. And so 180 degrees positive, it would be along this line, but then negative 180 is along the same line. So if you do -90, it's down here, or a positive 270 is the same vector. So you got to kind of watch those things. Like it's showing you, this is a plus 30, this is -120. So this is a plus 240, this is a -120. It's the same vector. This 4.2 angle of 240 is the same as 4.2 angle of -120. So whenever you do your calculations for your phase angle, you also have to take into account the signs of the two angles that you're, the component, the x and y component, or the r and x component. If you end up in this negative plane over here on the left side of the imaginary plane, sometimes you need to add 180 or subtract 180 to get it to make sense from what your calculator tells you. If your calculator, you get like example, if you get a 4.2 240 degree answer, if you convert it to rectangular form, you're going to get two negatives. You're going to get a negative for your imaginary and a negative for your real component. So like, see this example here. You're getting -6 plus J3. So this is a -6 this way and a plus J3 that way. So that, or this is two negatives. You're going to get a negative this way and a negative this way, and that's going to give you an angle of 230 degrees. So you have to kind of add 180 to it, because when you do the division, you do the arctangent of y over x, it's going to probably give you an angle up here, which is the complex conjugate of this true vector that you're looking for. So you'd have to add 180 degrees to it. So you kind of have to watch that. So getting back to this problem here, I actually got a different answer than the book got. I checked these two problems. You're much better off if you're going to do addition and subtraction. You're much better off converting each one of these to rectangular, or just typing them in your calculator as is. The book goes at length on how to do that if you use a TI-89. This is what the TI-89 looks like, and what you have to do when you type in any complex number, you have to put it inside of parentheses, and with rectangular, you have to use the I button. I don't know if you guys can see that, but that right there on the catalog, the blue, there's a blue I in there. That's going to be your imaginary. So if you had, let's say, 3 plus J2, you would type in parenthesis 3 plus second I 2 end parenthesis. That would be that one number. If you were going to do it in polar, let's say it was 5 angle of 30 degrees, you would put in parenthesis 5 and then put second and see where that angle is right there at the EE key. So you put in your parenthesis 5 second angle 30. Make sure you're in degrees too, and then hit right parenthesis. To make sure you're in degrees, you hit the mode button, and then you're going to want to scroll down. I can't show it on the screen, but you scroll down to the angle, and then you hit the down arrows right here to the angle, and then hit the right arrow key, this thing, and then you select degree, and then you hit enter. And then the same thing goes for complex format. You scroll down to complex format, hit the right angle, right arrow, and then you scroll up or down to either rectangular or polar, and then hit enter again, and then that'll change your default format. So I did this the long way. What I did was, I'm just doing part C here. This is just part C, and I converted each one of these. This 20 negative 120 here, I converted it to this, and then this minus 10 negative 150 here, converted it to that, and so on. And then I summed up all the x's and all the y's, and this is the answer I got. And then it ends up being 19.57 and an angle of negative 128.82. The book got this, and I believe what they did was they forgot to put in negative 150, because when I do that, it comes up with their answer exactly. So I think they messed up there. Okay, and the last problem is a phasor problem. They're saying problem number 53 is express the following in phasor form. Part A says 20 sine of 377t minus 180. So remember, if you have a sinusoid that looks like this, your phasor is like this, and you need to convert that max value to the RMS value by to get your RMS, you divide VM by the square root of 2. So you take your max value, which is 20, divided by the square root of 2, which ends up being 14.14. And then your angle is simply, if this is a sine, this angle right here as is, it's negative 180. So the answer is 14.14 angle of negative 180. Part B is 6 times 10 to the negative 6 of cosine omega t. Now that's tricky because you don't want cosines. You want to convert that cosine to sine. So you have to use the trig definitions. Cosine of A equals sine of A plus 90 degrees. Okay, so you're going to take that 6 times 10 to the negative 6 divided by the square root of 2. You get 4.24 times 10 to the negative 6. And you have to take that. This is really omega t plus 0. So you need to add 90 to whatever that angle is in there, which ends up being 0 plus 90. So then that's how they got 4.24 times 10 to the negative 6 angle 90. And part C, 3.6 times 10 to the negative 6 again times cosine of 754t minus 20. So you want to convert that cosine of a to sine of a plus 90. You have to take 3.6 times 10 to the negative 6 divided by the square root of 2. You get 2.55 times 10 to the negative 6th. And then your phase angle is going to be negative 20 plus 90, which is going to be plus 70. That's how they got that.